So welcome. So this is CAIE paper. CAIE. Let me write. June 2005 paper M1. All the 7 questions we are going to solve them. There are 7 questions in this one. So without wasting further time, let us start with the question. The first question says there is a small block on the rough horizontal floor with a constant speed, moving with a constant speed, or being pulled with a constant speed of 1.5 meters per second with a force 30 newtons at an angle theta. So let us draw the diagram first. In M1, the most important thing is we need to draw the diagram. So I got this is a block. Now this block is being pulled with a constant force. Okay, so I am pulling this one with a force at an angle theta, and this force is how much? 30 newtons. Given that the work done in 20 seconds is 720 joules. So what is this 30 newtons? So we have to resolve the forces. So this will be 30 cos theta. 30 cos theta. Okay, 30 cos theta. Then and over here will be, let me draw per, over here will be 30 sine theta. Apart from that, there will be a normal reaction R, and its weight mg is acting downwards. This is a basic diagram. The one in purple color is not required. Then also just we have done that one. Okay, now I want to do the work done. What is he given? That total work done is equal to 720 joules. Work done is nothing but what? Force times distance is equal to 720. What is a force? Because of which force it is moving? It is moving because of this 30 cos theta. So the force is 30 cos theta. Distance because it is moving with a constant speed, right? So in that case, distance is equal to speed times time. Speed times time should be equal to 720. So from there, 30 cos theta is equal to speed is 1.5, time is 20, is equal to 720. So from there, cos theta is equal to 720 divided by 30 times 1.5 times 20. So theta is equal to cos inverse of this entire thing. You can use the full calculator display. Don't use any rounding numbers. So I get it out in 3 significant figures or 1 decimal, 36.9 degrees. So that's a simple answer. Coming to question number 2. What does that question number 2 says? This is a diagram. So first thing we have to do it out is, remember, we have to resolve all the forces. As soon as you see such kind of diagrams, we have to resolve all the forces. 7 newtons, no need to do because it is already horizontal. 5 newtons. So I'd use a different color for 5 newtons. Let it be red color. So 1 horizontal, 1 perpendicular or vertical. 1 horizontal, 1 vertical. This is 5 and degrees is 50. So 5 cos 50. And the other one will be 5 sine 50. Okay, so let me write it out side by so that it doesn't blocks. So this is 5 sine 50. Now 6 newtons. Okay, so 5 newtons is that direction. So I have used red color for the 5 newtons. Now let me use a different color, maybe blue color for 6 newtons. This is 6 newtons. So I will be resolving 1 downwards. It's not coming. 1 downwards and 1 towards your left. So this one will be 6 cos 30 and this one will be 6 sine 30. Basically in these questions compulsorily there will be the word equilibrium. So there will the body will be in equilibrium. Okay, or he's asking what is the magnitude of the resultant of the forces. So we can see that what all the forces are acting on the horizontal. So first we take for horizontal forces. So it is 7 newtons on the right side plus 5 cos 50 on the right side, but 6 cos 30 on the left side. So 6 cos 30 on the left side. This is on x-axis, capital X. Let us think. Then vertical. What are the forces vertical? Let it be y. What I can do that 5 sine 50 on the upside minus 6 sine 30 on the downside. These are the forces. Now if I want to simplify this one, or I want to find the resultant, right? So resultant will be square root of x square plus y square. So take these values. I'm directly using the value what it says from the calculator. If I do that one, let me quickly pull the calculator, and it says 7 times 5 times cos 50. See that the mode of the calculator is in degrees mode. 6 times cos 30. So when I do that one, I should be getting it as 5.017785626. Similarly, when I do 5 times sine 50 minus 6 times sine 30. So when I do that one, I should be getting it as 0.83042.156. So I'm going to take those values and find it out. So it is 5.01 so on whole square plus 0.83 so on whole square, and my final answer should be finding it out the magnitude in 3 significant figures, 5.09 newtons. This is R. Next, what should I be finding it out? Find the magnitude has been found. Direction. So R, I have to find it out. So tan theta. So every time tan theta will be the y coordinate by x coordinate. So y coordinate value is 0.8302 and so on. Take full calculator display divided by 5.0177 and so on. So that is tan theta. So theta is equal to tan inverse of that answer, which should be giving you 9.4 degrees. 9.4 degrees. And you can see that what is the resultant value? It should be in the 9.4 degrees. 9.4 degrees. So that is the answer. I'm going to find it out. Or you can write the angle as 9.4 degrees anti-clockwise from the force of magnitude 7 newtons. From the force of magnitude 7 newtons. So because the question is asking up to the direction, you should be able to tell the direction also. So how I know that it is from the force 7 newtons? Basically, we got x value as a positive, y value also as positive. X value positive and y value positive means it should be in the first quadrant. So first quadrant base is nothing but what? 7 newtons. So therefore our angle should be always mentioned with respect to the positive x-axis or 7 newtons. So I told it out in the 7 newtons, and x is positive, y is positive means it is going upwards. So in the sense it is an anti-clockwise direction. So remember to write the word anti-clockwise direction from the force of magnitude 7 newtons. Now question number 3. So what is this question number 3? A and B are points on the same line of a greater slope of a rough plane. So rough plane inclined at an angle 30 degrees to the horizontal. So let me draw the diagram. So this is a plane. The angle of inclination is 30 degrees. Okay, and he says as A is a higher up and B is a lower point. So there may be 2 points. Let me mark this point. A is over here and B is over here. And what is the distance between them? 2.25. 2.25 meters. Distance AB. The particle A of mass m is released from rest A. So there is a particle of mass m. So let me draw this particle. Okay, it is released from A, from rest A. So initial velocity is equal to u is equal to 0, and reaches B in 1.5 seconds. So T is equal to 1.5 seconds. Find the coefficient of friction. Find the coefficient of friction. So what has happens is, so as soon as you see these kind of questions, first again we have to resolve the forces. Resolve. So what am I going to do? I am going to resolve those forces. So how the mass of that particle is m, right? So first mg, then it will slide because of the one force mg sine theta over here 30, and it will have one force over here mg cos theta cos 30, and one force over here which is normal reaction. Now as such it is sliding down, and it says that it is a friction rough plane, so therefore there will be an opposite force mu r. Okay, so that's the opposite force. So simple, remember, very simple formula. Maybe you know not be getting it out in another videos or another explanations. Very simple formula to remember. Forward force minus backward force is equal to ma. If you remember this standard formula, then automatically you will be able to solve minimum 4 questions from M1. Forward force minus backward force is equal to ma. So this, it is sliding down, so my forward force will become mg sine 30. My backward force will become mu r is equal to ma. M times acceleration. Acceleration I don't know. Okay, so first I will try to find it out the acceleration. How should I find the acceleration? So initial velocity is 0, time is equal to 1.5, and distance is 2.25 meters. So I use s is equal to ut plus half at square. So from there 2.25 is equal to 0 times t is 1.5 plus half a times 1.5 square. From there a value I get it as 2. So I use all these values now. So mg, so I can see that mg, g is 10, sine 30 is 1 by 2 minus mu value I don't know, we have to calculate that. R, you can see that r is balanced with mg cos theta. So mg, g is 10 and cosine 30 is equal to m times a. We can see that m gets cancels. Then from there I get 5 is equal to 5 minus mu times 10 cos 30 is equal to 2. So mu times 10 cos 30 is equal to 5 minus 2. So mu is equal to 3 upon 10 cos 30. We quickly take the calculator. 3 divided by 10 times cos 30. I check by calculator and get that answer is root 3 upon 5. My calculator gives me root 3 upon 5, but we need to write in 3 significant figures, so mu is equal to 0.346. This is answer for question number 3. Question number 4, another simple question. A particles of masses 0.2 kgs and 0.3 kgs are connected by a light inextensible string. The string passes over a smooth pulley at an edge of a rough horizontal plane, rough. Particle A hangs freely, particle B is in contact with the table. The system is in limiting equilibrium, the word limiting equilibrium, with the string being taut, and A is about to move downwards. That's the most important thing. The motion is always downwards in this question, means B is moving in this direction, A is going downwards. Find the coefficient of friction, 4 marks question. Okay, so as soon as you see the question, first of all we have to resolve the forces. I said every time resolve the forces. B is 0.3 kgs, so 0.3 g. A is 0.2, so 0.2 g. Tension will be acting towards the pulley every time. Tension will be acting towards the pulley, so that is tension T, towards the pulley. Now A is moving down, right? So I remember, if you remember in the previous question I told you to remember one formula, right? What was that formula? If you can remember, every time forward force minus backward force is equal to ma. That's a basic thing. forward force minus backward force is equal to ma. For A, now I write it out. For A, the forward force is 0.2 g, it is coming downwards, minus backward force is t, is equal to 0.2 a. Okay, now B is on a rough plane. If at all you can read the question or remember the question, it was on a rough plane, so there would have been some friction, so which is mu r. So what is r? Right over here, which is r. So in that case, for B, what is the forward force? The forward force is tension, it is going towards left because of the tension, minus backward force is mu r, is equal to ma 0.3 a. So what am I going to do? I am going to find it out, the coefficient of friction between the table and this one. So I need to find the acceleration also. Do I know the acceleration? I don't know the acceleration. So if I don't know the acceleration, so how should I be able to find it out? Mu, that is a major part of the question. Now it is saying that it is in a limiting equilibrium. So whenever it is in the limiting equilibrium, what I can say, that is, it's not moving. If at all, it's not moving. So in the limiting equilibrium, this is the most important thing. Whenever it is in limiting equilibrium, I take acceleration is equal to 0. So my new equation will be 0.2 g minus tension is equal to 0. Tension minus mu r is equal to 0. I do then solve those two equations. Tension gets cancels, so I get it out. 0.2 g minus mu r is equal to 0. So 0.2 times 10 is equal to mu times r. R is nothing but what? When you see the diagram, r is balanced with 0.3 g. So 0.3 g is again 10. So 10 gets cancels, so mu is equal to 0.2 upon 0.3. So mu value is 2 upon 3. As simple as that. So I use the same formula, forward force minus backward force is equal to ma, but acceleration will be equal to 0 whenever it is in limiting equilibrium. That is the first part. Now what is happening to the second part? Let us go to and read the second part. A force now acts on a particle B. This force has a vertical component 1.8 newtons upwards and a horizontal component x newtons directed away from the pulley. So that's a good question. So what am I going to do? Erase these unnecessary diagram or this part. Now there is a force. Let me have a different color for that. Vertical component 1.8 newtons. So there is a vertical component 1.8 newtons. I'm drawing that one there. 1.8 newtons and a horizontal component x newtons directed away from the pulley. X newtons directed away from the pulley. So that is on the B. The system now is still in limiting equilibrium, and A is about to move upwards. It is about to move upwards now. Okay, last time it was moving downwards, now it is about to move upwards. If at all it is about to move upwards, means B is moving towards your right. Same thing every time, it's same thing. So what is that? Forward force minus backward force is equal to ma. Very silly part, is equal to ma. Now when B is moving towards the right side, in the sense this friction will be on the opposite side. It goes towards left side. Okay, because friction is always the opposite force. Okay, so that's my opposite force. Now I have to find it out, the value of x. So how should I be able to find the value of x? So we know that forward force minus backward force is equal to ma. So for A, let us do by A. Coming to A, the forward force is tension because it is going upwards, minus backward force is 0.2 g, is equal to, it is in equilibrium, right? 0. Okay, ma. For now, for B, the forward force is x newtons because it is going towards right. X newtons is a forward force. Backward force are two things, mu r and the tension. Minus mu r minus tension is equal to 0. I am going to solve these two equations. So tension gets cancels. X minus mu r minus 0.2 g is equal to 0. So I get it out x value, which is mu r plus 0.2 g. Mu is 2 upon 3 r. What is r value? When we go back to the question, we can see that 1.8 plus r is balanced by 0.3. So I write it out over here with a different color. R plus 1.8 is equal to 0.3 g. So r is equal to 0.3 g minus 1.8. So 0.3 g minus 1.8. Okay, so when I fill that one, so what should I be getting it out, which is 2 by 3 times 0.3 g minus 1.8. So when I get, and don't forget to add 0.2 g, which is plus 10. So when I do that one, this one I get it as 0.8 plus 2. So my final answer is 2.8. That's going to be the answer. So simple formula, forward force minus backward force is equal to ME. Question number 5. The velocity at t is 0.03 t square. When t equal to 5, the displacement of the particle from the origin O is 2.5. So he has given velocity is equal to 0.03 t square. So in order to convert velocity into displacement, I need to do the integration on both sides. 0.03 t square dt. So displacement is equal to 0.03 t cube by 3 plus c. But it has been given that when t is equal to 0, s is equal to 2.5. So what am I going to do? I'm going to substitute 2.5 is equal to 0.01. T is 5 cube plus c. From there, I get the value of c as 1.25. So what is the formula for the displacement? X or s is equal to 0.01 t cube plus 1.25. That's the answer for the displacement. Find an expression. Next, what else has been asked? Find the velocity of p when the displacement is 11.25. So we take the same thing, but the displacement has been given as 11.25 is equal to 0.01 t cube plus 1.25. So 0.01 t cube is equal to 10. T cube is equal to 1000. So t is equal to 10 seconds. But is he asking time? No, he's asking us to find the velocity v. So go back and substitute in the formula for v. So what was the formula for v? 0.03 t square. So 0.03 times 10 square. So velocity is equal to 3 meters per second. That's going to be the answer for question number 5. Coming to question number 6. The diagram shows the velocity graph for a lift moving between the floors in a building. The graph consists of a straight line segments. In the first stage of the graph, the lift travels downwards. That's why the graph is in the negative side from the ground floor. If at all it is moving from the ground floor, the displacement will be negative for 5 seconds. And coming to rest at the basement for 10 seconds. So from 5 seconds to 15 seconds, it is at the rest. Find the greatest speed reaching during this stage. So what is this v? Let it be the greatest speed v. The basement distance is 10 meters. So remember that any time area gives me the distance. Area is equal to the displacement or distance. So I have to know that area of the triangle is equal to area of the triangle in a velocity time graph, area gives you the displacement. Area of the triangle is equal to 10. So half times base times height is equal to 10. Half times base is 5, height is the velocity v is equal to 10. So from there, v max, we can tell maximum velocity. V max is equal to 20 by 10, which is 20 by 5, which is 4 meters per second. So what is the maximum speed it can go through? Reaches 4 meters per second. From 0 to 5, it went down basement, then stayed there for 10 meters, 10 minutes or 10 seconds. Then in the second stage, it consists of 10 seconds wait at the basement. It waited 10 seconds at the basement. In the third stage, the lift travels upwards. That's the reason the area is in the positive upwards. It comes to rest in 34.5 seconds. Above the basement, arriving 24.5 seconds after the start of the first stage. So after the start of the first stage, it is totally taking 24.5 seconds, and the height it is 34.5 meters. The acceleration of the lift is 2 meters per second for the first 3 seconds, that is from 15 to 18, reaching a speed of v. Over here he's used a v. Find the value of v. So we can see that from 15 to 18, how much is the duration? 3 seconds, right? So time is equal to 3 seconds. Initial velocity, it was starting with the velocity 0, and final velocity is v, and acceleration is equal to how much has been given? Acceleration is 2. So I can find it out, the v value. So how do I find it out, the v value? V is equal to u plus at. So v is equal to 0 plus a is 2 times 3. So I get v is equal to 6 meters per second. As simple as that. Find the value of v. 2 marks, I got it. The time during the third stage for which the lift is moving with a constant speed. We can see that this part is the constant speed from 18 to some part. How should I be finding it out? We know that the total distance is nothing but what? 34.5. So it looks like a trapezium. So area of a trapezium should be equal to 34.5. So I use that. Again, the same concept. Area is equal to 34.5. Area of a trapezium formula, half times a plus b times h is equal to 34.5. So half times a means the parallel sides, length of the parallel sides. The first one I may not be knowing it out, plus b. From 15 to 24.5, how much is that? 9.5. Let that be b, 9.5. Height is the velocity v, because when we go height is nothing but what? Velocity v, which just now we got it as 6. Okay, so 6 is equal to 34.5. From there I get the value of this 3. So a plus 9.5 times 3 is equal to 34.5. A plus 9.5 is equal to 34.5. 34.5 divided by 3, which is nothing but what? 11.5. So from a is equal to 2 seconds. So what is the duration for that? It is moving with a constant speed, 2 seconds. Now he is asking finally, what is the deceleration of the lift in the third stage? Deceleration. So 2 seconds, right? It's already, let me erase over here, it's already 18 seconds. So 18 plus, if at all I draw over here, 2 seconds, 20 seconds. So deceleration is from 20 to 24.5. 20 to 24.5. So during the deceleration, so the time is 24.5 minus 20, which is 4.5 seconds. And initial velocity, it was moving with 6 meters per second. It's coming to rest, right? So 0. Deceleration is equal to how much? It is being asked. Okay, so I use the word v is equal to u plus at. V is 0, u is how much? 6, plus a I don't know, t is 4.5. So a is equal to 6 divided by 4.5. So minus 6 divided by 4.5, which is negative 4 upon 3 meter per second square. This is acceleration, but he's asking deceleration, remember. So you have to write deceleration is equal to positive 4 upon 3 meter per second square. That's the answer for the question number 6. Finally, question number 7. What is being asked? A car of mass 1200 kgs travels along a horizontal straight road. The power provided by the car's engine is constant and is equal to 20 kilowatts. The resistance of the motion is 500 newtons. The car passes through point A and B with a speed of 10 and 25. Car takes 30.5 seconds. Find the acceleration. Our standard formula: forward force minus backward force is equal to ma. As simple as that. See, 4 questions are based upon this simple formula in M1. Forward force, because it is a power, right? The question is based on the power force. So what am I going to do? Whenever I have a power, the question based upon power, my forward force is because of the car's engine. Okay, so which is nothing but what? Power by the velocity. Power by velocity is a forward force, minus backward force is my resistance, which is 500, is equal to ma. M is 12,200, 1,200 a. So what is the power? 20 kilowatts. 20,000 divided by the velocity at a. I'm talking about at a, so divided by 10 minus 500 is equal to 1,200 a. From there, 2000 minus 500 is equal to 1200 a. So a is equal to 1500 divided by 1200. So I get it out. A is equal to 1.25 meters per second. That is the acceleration. Very simple, because it's asking at a, so therefore I have taken the velocity at a. So in case of power sums, forward force will be power divided by velocity. By considering work energy theorem, calculate the distance d. So very simple question, work energy. So you have to use only simple formula, TWD. What is TWD? Total work done. Total work done is equal to delta KE plus delta PE plus WDF. What is this WDF? Work done against friction. Work done against friction. So total work done is equal to delta KE plus delta PE plus work done against friction. So I have to find it out, the total work done. Now A to B is, what is the distance between A to B? Has he given the distance between A to B? He has not given the distance between A to B. So what am I going to do? First of all, I have to find it out, the delta KE. So I will find delta KE, then I'll plug in all these values over here. Okay, so I have a space to find. Okay, a lot of space is there, so I go down, find delta KE first. Delta KE means final kinetic energy minus initial kinetic energy. So final kinetic energy minus initial kinetic energy. Final kinetic energy 1 by 2 times 1200 times final velocity was 25 square, minus 1 by 2 times 1200 times initial velocity was 10 square. So when I do that one, let me quickly pull the calculator. 200 times 25 square minus 1200 times 10 square. So when I get that one, I get 315000 joules. This is the delta KE. Now what is happening? PE, does it have a PE? Because it is moving on a horizontal road, right? So delta PE will be equal to 0. So there is no change in the potential energy. Now work done by the car, total work done by the car. Okay, now work done by the car. So how do I know the work done? Total work done. Total work done is equal to, how should I be using it out? The total work done. Work done by the car. So over here I have, you remember, power. Power, how much I have? 20 kilowatt. 20,000. Okay, so we know the formula. Power times time. Power times time. Power is 20,000 times time is how much seconds? 30.5 seconds. So total work done will be 610,000 joules. Because I use the verb formula, power is equal to work divided by time. So work is equal to power times time. That formula has been used. Now work done against friction. I don't know. Work done against friction. Work is nothing but what? Force times distance. Force times distance. So resistive force is 500 times distance is AB. So now we plug in all the values over here. So just now we got total work done was 610,000. Delta KE was 315,000 plus delta PE was 0 plus work done against friction was 500 times AB. From here I get 500 times AB is equal to 610,000 minus 315,000. So 500 AB is equal to 295,000. So AB is equal to 295,000 divided by 500, which gives me AB is equal to 590 meters. That's all. So that's going to be the answer for the 7th question. That completes our paper. See you in the next paper.